So let's evaluate this integral where our region is given by x squared plus y squared is less than or equal to 9, x is greater than 0, y is greater than or equal to 0. What do these two inequalities mean? R is in the first quadrant, right? So in fact, if we draw it, okay, if you think of the equality associated with this inequality, what is that? X squared plus y squared equals 9 is a circle of radius 3. So let's say for the sake of argument that this is 3 on the x-axis, this is 3 on the y-axis, got stretched out somehow. We want to evaluate it in polar coordinates. Okay. Before we find the limits of integration, what would x be in polar coordinates? R cosine theta. What would y be in polar coordinates? R sine theta. dA, your area element, r dr d theta. Yep, that's what the pirate would say. And then, okay, if you're in polar coordinates, then think of the spoke. So this is your region, right? Think of a spoke. In this case, it does start at the origin, goes over the entire region, and then ends at the border, which is a part of the circle, right? So the ends of the, radially, the ends of that spoke give you your inner limits of integration. So what are they? 0 to 3. Okay, now, here's a good way to visualize it. If I draw a little line segment here. So here's my spoke, right? I have to scan the entire region with that spoke. So how is this angle changing? What's the low? What's the high? 0 to pi halves. And how does that simplify? Well, inside. R cubed, and then it should be pi over 2. I just got in a hurry. There we go. Okay. And then r cubed, cosine theta, sine theta in there. Too much orange. dr d theta. You can separate it. What would it look like if you separate it? The integral from 0 to pi over 2, what would go inside? Cosine sine. And then d theta, right? Times integral 0 to 3. R cubed dr, right? Now, how do we integrate this? You could use a trig identity. You don't have to. You could do a u substitution. What would you let u equal? Well, it'd be easiest to let it be sine theta, because then du is cosine theta d theta, right? So, in fact, you have your perfect u if you do that. So what do you get? You have your perfect du if you let u equal sine theta, because du would be cosine theta d theta. So what's the antiderivative then? 1/2 sine squared theta, evaluated from 0 to pi halves. What does this guy become? 1/4 r to the 4th. Evaluated from 0 to 3, right? So for this guy, what do we get? If we plug in pi over 2, 1 minus 0 times 1/2 is 1/2 times 1/4 times 3 to the 4th, which is 81. What do we get then? 81 over 8